It lasted 19 minutes. 19 minutes in the dark, after 11 o'clock at night, on a quiet stretch of North Dakota prairie. 19 minutes where the wind didn't just blow, it screamed. Where the air didn't just move, it became a weapon. And in those 19 minutes, it broke a 12-year national drought, not of rainfall, not of severe weather, but of the strongest, most violent, most devastating tornado rating on Earth. EF5, the kind of tornado that meteorologists talk about in hushed voices, the kind that rewrites textbooks, the kind that most people will never see in their lifetime. Tonight, we tell the true story of Enderlin, North Dakota, minute by minute, life by life, choice by choice. How? Science, luck, human resilience, and 33 derailed train cars changed everything. How a single-toss tanker, thrown nearly 5 football fields through the air, forced meteorologists to rewrite the record books 4 months later. Because here's what most people don't know. Here's the part that makes this story different. When the sun rose on June 21st, 2025, when the damage surveyors first walked the track, when the media descended on this small North Dakota town, the official rating was EF3. Strong, yes. Deadly, absolutely. Catastrophic for those in its path. But EF3, 160 miles per hour. Devastating, but not unprecedented, not historic, not record-breaking. Then, they found something in the rail yard, something massive, something that couldn't be explained away, something that couldn't be argued with, something that proved the winds were far more powerful than anyone first believed. This is Enderlin, North Dakota, June 20th, 2025, 11:02 p.m. Central Daylight Time. Population, 874 souls. Track length, 12.1 miles. Duration, 19 minutes. Fatalities, 3. Rating, eventually, EF5. The night America's 12-year EF5 drought finally ended. Enderlin sits in the Red River Valley of southeastern North Dakota. If you blink driving through on Highway 46, you might miss it entirely. 874 people, one main street, a grocery store, a post office, a couple of churches, the kind of town where the Friday night high school football game is the biggest event of the week. Farm country, endless horizons, fields of wheat, soybeans, corn stretching out in every direction like a patchwork quilts, stitched by generations of families who've worked this land for over a century. Grain elevators tower over the landscape like sentries. Railway tracks cut through town, carrying those harvests to markets across the country. The BNSF line runs right through the heart of Ransom County. It's quiet here. Peaceful. The kind of place where people leave their doors unlocked, where neighbors help neighbors bring in the harvest, where everyone waves when they pass on the road. The sky is always big in North Dakota, bigger than anywhere else, locals will tell you. You can see weather coming from 50 miles away. Storm clouds build on the horizon like mountains. And on June 20th, 2025, those clouds were building, but we're getting ahead of ourselves, because to understand that night, we need to understand the days leading up to it. June 15th, 2025. 6 days before the tornado, the Storm Prediction Center in Norman, Oklahoma issued their Day 6 outlook. For most people, this is meaningless, technical jargon, colored polygons on a map. But for meteorologists, it's a signal. The ingredients were aligning. A potent upper-level trough digging into the northern plains. Gulf moisture streaming northward. Wind shear. Strong wind shear, the kind that makes supercells rotate, the kind that makes tornadoes possible. The outlook mentioned eastern North Dakota. Just a slight risk, a marginal mention. But it was there. By June 18th, Day 3. The forecast confidence grew. By June 19th, Day 2. The Storm Prediction Center upgraded the region to moderate risk. Now, understand. Moderate doesn't mean middle of the road. In Storm Prediction Center language, moderate risk means significant severe weather is expected. Tornadoes are likely, Some could be strong, possibly violent. Local National Weather Service offices started briefing emergency managers. Storm chasers began planning routes. News stations in Fargo started running "Stay Weather Aware" segments. But here's the brutal truth about tornado forecasting. We can see the ingredients. We can watch the atmosphere load like a gun being cocked. We can identify regions where tornadoes are likely. But we cannot tell you exactly where the trigger gets pulled. We can say eastern North Dakota. We can even say Ransom County, Cass County. But we cannot say 3.8 miles south of Enderlin at 11:02 p.m., a tornado will touch down that will kill 3 people and throw a tanker car almost 500 feet. We're not there yet. We may never be there. So, on the afternoon of June 20th, people in Enderlin knew storms were coming. They'd heard the forecasts. They'd seen the warnings. But life went on. Tyler Pfaff went to work. His wife Brooke ran errands. Michael and Katherine Dehn, both 73, went about their day on their property just southeast of town. Macario Lucio, 89 years old, was home. They all knew. Storms were possible. None of them knew what was about to happen. By late afternoon, the atmosphere was primed. Dew points in the upper 60s, low 70s, instability measures off the charts. Cape values over 3,000 joules per kilogram. For non-meteorologists, that means the atmosphere was loaded with energy, like a spring compressed to its absolute limit. And the wind shear. Oh, the wind shear. Surface winds from the southeast. Winds aloft from the southwest. Speed shear, directional shear. The kind of environment that doesn't just support rotating thunderstorms, it demands them. By 6 p.m., towers started going up near Jamestown, about 60 miles west of Enderlin. By 7:30, the first tornado warnings were issued. By 8 p.m., storm chasers were reporting multiple tornadoes on the ground. This wasn't a single storm event. This was an outbreak. EF2 near Spiritwood Lake. EF3 east of Jamestown. Another EF2 near Eccleston. One after another, supercells marched across the North Dakota prairie like an invading army. Radar screens lit up with hook echoes, debris balls, velocity couplets. Every signature you don't want to see was there. And by 10 p.m., one particular supercell, one beast of a storm, was tracking east-northeast toward Ransom County. Storm chasers repositioned. Law enforcement started rolling. The National Weather Service issued a tornado warning for Ransom County at 10:43 p.m. and at 10:47. Tyler Pfaff's phone screamed with the alert. He was home with Brooke. Their house, a modest single story, sat on a rural property just southeast of Enderlin. No basement, just a bathroom, interior walls, the safest place they had. Tyler looked at Brooke. She looked back. They both knew. This wasn't a maybe. This wasn't a just in case. This was happening. By 10:55, the storm was close. You could hear it. Not just thunder, that deep, guttural, continuous roar that sounds like a freight train, like a jet engine, like the earth itself tearing open. The wind picked up. Not gusty. Steady, pushing, building. Tyler and Brooke grabbed flashlights, a battery-powered radio, their phones. They moved into the bathroom, closed the door, and they waited. The lights flickered, then darkness. Power out. In the pitch black, with only the glow of their phone screens, they could hear it getting closer. Tyler later told a reporter from Inforum, "We closed the door to the bathroom. We sat there. I was praying. I was like, it's going to get us." 3 miles south, Michael and Katherine Dehn were taking shelter too. 6 miles south, Macario Lucio, 89, was hunkered down. And at 11:02 p.m., exactly, 3.8 miles south-southwest of Enderlin, the tornado touched down. 11:02. EF0 at first. Maybe 50 yards wide. Winds around 85 miles per hour. The kind of tornado that tears up crops, snaps a few trees, maybe damages a shed. Not catastrophic, not violent, not yet. But this tornado had other plans. Within 60 seconds, it began to intensify, not gradually, not in neat, measurable increments, explosively. The condensation funnel widened. The debris cloud at the base expanded, and as it crossed open farmland, moving east-northeast at 40 miles per hour, it went from EF0 to EF1 within a minute, EF1 to EF2 in another minute, by 11:05, maybe 11:06, EF4, and it was still intensifying. This is what meteorologists call rapid intensification. It's rare, it's terrifying, because there's no time to issue a new warning, no time to say, this just got worse. The tornado warning was already out. People were already sheltering, but the storm was exceeding every expectation. At 11:07, give or take 30 seconds, the tornado reached the ADM agricultural facility, grain silos, storage buildings, metal structures, and the railway line, the BNSF railway tracks that cut through Ransom County, carrying grain hoppers, tankers, flat cars, freight across the northern plains. On that night, on that stretch of track, 33 rail cars were sitting. Some were empty. Some were partially loaded. Some were full. Grain hoppers, each one weighing over 200,000 pounds when fully loaded. Tankers, massive cylindrical steel containers built to carry liquids, fuels, chemicals. These aren't lightweight structures. These are engineered objects, built to strict standards, known weights, known structural thresholds. The tornado hit them head on, and what happened next is why this story exists. The tornado didn't just derail them. Derailment is EF2, maybe EF3 territory. Strong winds can tip a rail car, especially an empty one. No, the tornado lofted them, picked them up, threw them. One tanker car, partially loaded, weighing conservatively 15 to 20,000 pounds, was thrown 475 feet. Let me say that again, slower, so the magnitude sinks in. 475 feet. That's 158 yards. That's more than 1.5 football fields, end to end. A tanker car. Steel. Heavy. Not a lawn chair, not a piece of plywood. A train car, thrown, and grain hoppers. Fully loaded, each one 250,000 pounds of steel and wheat, tipped, rolled, shoved off the tracks like toys. When engineers analyzed this later, when they did the math, the wind speeds required to loft that tanker, over 210 miles per hour, minimum. That's not EF4, that's not strong, that's EF5. But the trains weren't the only evidence. As the tornado continued east-northeast, now at peak intensity, it reached its maximum width, 1.05 miles, over a mile wide. Imagine standing on one side of this thing and not being able to see the other side through the rain, the debris, the darkness. A mile-wide vortex at night winds over 200 miles per hour, churning across the prairie like a buzzsaw. It crossed the Maple River, and there, in the forest along the riverbank, it left a signature that made even veteran storm surveyors, people who've seen hundreds of tornadoes, stop cold, trees, sandpapered, not snapped. Tornadoes snap trees all the time. EF2, EF3, you get snapped trunks, not uprooted. EF3, EF4, you get trees ripped from the ground, root balls exposed. This was different. The bark was gone, stripped, debarked, scraped down to bare wood like someone had taken an industrial sander to every trunk in the forest. Branches? Gone, obliterated, not broken off, disintegrated. The canopy? A memory. What remained looked like a field of wooden spikes, pale, naked trunks, some still standing, some sheared off at 10, 15 feet. One National Weather Service surveyor described it as looking like the trees had been put through a grinder. Another said it looked sandblasted. This kind of damage requires winds so violent, so laden with high-velocity debris, that the forest essentially becomes a scoring pad. Dirt, gravel, wood fragments, metal shards, all traveling at over 200 miles per hour, shredding everything in their path. This isn't EF3. This isn't even EF4. This is EF5 tree damage. Textbook. Undeniable. At 11:11 p.m. The tornado crossed North Dakota Highway 46. 2 homes sat near that intersection. Rural properties, small houses, not mansions, not fortresses, just homes. The tornado erased them, completely. Foundations swept clean, not just walls collapsed, removed. Debris scattered so far downwind that investigators found pieces of one house over a mile away. One of those homes belonged to Michael and Katherine Dehn, 73 years old, both of them, married for decades. Tyler Pfaff's aunt and uncle. They had taken shelter. They had done everything right. But the tornado? The tornado doesn't care about preparation. Michael Dehn was killed. Katherine Dehn was killed. 6 miles south at another property in the path. Macario Lucio, 89 years old, was killed. 3 lives, 3 families, 3 funerals. Tyler and Brooke Pfaff huddled in their bathroom just a half-mile away. They heard it. The roar, the impact, the sudden awful silence after. Their home was obliterated. Roof gone, walls collapsed, furniture scattered across the field. But the bathroom held. Just barely. Tyler would later say, voice shaking, "Thank God we're alive." But in the same breath, he'd think of Michael and Katherine, and he'd break, because survival comes with guilt. Why did their bathroom hold? Why did Michael and Katherine's home get scoured to the foundation? There's no answer, no logic, no fairness, just chance. Construction differences, the exact path of the vortex, luck or the lack of it. Transmission towers along ND 46 toppled like dominoes. Massive steel lattice structures, designed to hold power lines in 80-mile-per-hour winds, buckled, twisted, collapsed. Ransom County went dark, and the tornado churned on. At 11:18, 11:19, the tornado began to weaken, not die, not vanish. Weaken, it wobbled, looped slightly to the north. The condensation funnel became ragged, less defined. By 11:21 p.m., 19 minutes after it began, near the town of Alice, North Dakota, the tornado dissipated, gone, just gone. Like a switch had been flipped, like the atmosphere said, enough. The rain continued, the lightning continued, the storm rolled eastward into Minnesota, but the tornado was over. Total track, 12.1 miles, peak width, 1.05 miles, duration, 19 minutes, fatalities, 3, and Enderlin itself, the town proper, was mostly spared. The tornado passed just south and southeast, close enough to cut power, close enough that residents heard it. Some even saw the lightning illuminating the funnel in brief, horrifying flashes. But the main streets, the school, the homes in town, intact. Mayor Dehn would later tell the Associated Press, almost in disbelief, the city of Enderlin went unscathed. It sounds like a miracle, and in many ways, it was. The tornado could have turned, could have tracked 2 miles north, could have gone straight through downtown. It didn't. But for the families along that 12-mile track, for Tyler and Brooke, for the Dehns, for the Lucio family, for the farmers who lost barns and equipment and years of work, there was no miracle. Just wreckage, just loss, just the work of rebuilding. When the sun rose on June 21st, 2025, the scope became clear. A scar cut across the earth, visible from space. Satellite imagery showed a brown gash through green farmland, over a mile wide in places, stretching 12 miles from southwest to northeast. Aerial footage, shot by drones and helicopters, showed the devastation in brutal detail. The train cars crumpled and scattered like a child's toys. The forest along the Maple River, reduced to pale wooden stubs. The foundations where homes used to be, now just concrete pads and scattered debris. Power lines down, roads blocked, fields churned into unrecognizable mud. Emergency crews mobilized at first light. Search and rescue teams from across North Dakota converged on Ransom County. Governor Doug Burgum toured the damage. He stood at one of the swept foundations and said quietly, "This is catastrophic." Volunteers poured in. Red Cross set up shelters. Churches organized meal trains. Neighbors from unaffected areas brought chainsaws, trucks, helping hands. This is what small-town America does. When disaster strikes, you show up. Tyler Pfaff stood in what used to be his living room. No roof, no walls, no furniture, just foundation and memories. A reporter from Inforum asked him how he was doing. He stared at the wreckage for a long moment. Then he said, voice cracking, "We closed the door to the bathroom. We sat there. I was praying. I was like, it's going to get us." He paused. "Thank God we're alive." But you could hear it in his voice, the unspoken other half. But they're not. Brooke, his wife, found a family photo in the rubble, crumpled, water-stained, the glass broken, but intact. She held it to her chest and cried. These are the moments, the human moments, the ones that don't fit into damage surveys or wind speed calculations. Because no matter what the rating is, whether it's EF3 or EF5, grief is grief, loss is loss, and no enhanced Fujita rating brings anyone back. In the days following June 20th, the National Weather Service began their damage surveys. Teams of meteorologists fanning out across the 12-mile track, documenting everything. They photographed foundations, measured debris throw distances, analyzed tree damage, examined the transmission towers, and they issued a preliminary rating. EF3, estimated winds, 160 miles per hour. Devastating, yes. Deadly, absolutely. Catastrophic for those in the path. But EF3. Now, understand. EF3 is a strong tornado. It's in the top 15% of all tornadoes. It can level well-built homes. It can kill. But EF3 isn't historic. The United States sees a handful of EF3s every year, sometimes a dozen or more in a bad season. So, when the preliminary rating came back, EF3, it was tragic, yes, but not unprecedented. Except something didn't sit right. The damage at the Maple River Forest, the transmission towers, the way those homes were obliterated, not just destroyed, and the trains. The National Weather Service knew about the derailed cars, but the initial survey team didn't have time to fully analyze them. They saw the damage, noted it, moved on. Standard procedure. You do a quick survey, issue a rating, then, if needed, come back for a deeper analysis. And that's exactly what happened, because here's the context that makes this matter. The United States hadn't seen an EF5 tornado since May 20th, 2013. Moore, Oklahoma, a monster, a legend in tornado circles, 2.6 miles wide at peak, winds up to 210 miles per hour, tracked 17 miles through the Oklahoma City metro area, 24 people killed, over 200 injured, entire neighborhoods erased. It was the last EF5, and after more. 12 years passed, 12 years, hundreds of tornadoes, dozens of violent storms, multiple EF4s, but no EF5s. Some scientists started to wonder, was it a fluke? Were building codes better now, making it harder to reach EF5 damage thresholds? Was climate change shifting tornado patterns, making violent tornadoes less common? Or were we just missing them? Were EF5s happening in open country, hitting nothing substantial, and getting underrated? The EF5 drought, as it became known, was a hot topic in meteorology circles. Papers were written, conferences held, debates raged. And then, Enderlin. October 6th, 2025, 4 months after the tornado, the National Weather Service office in Grand Forks issued a statement. After extensive collaboration with structural engineers, wind damage experts, and researchers, after detailed analysis of railcar displacement, debarked timber thresholds, and transmission tower failure modes, the Enderlin, North Dakota tornado of June 20th, 2025, has been upgraded from EF3 to EF5. Estimated peak winds in excess of 210 miles per hour, EF5, the first EF5 in the United States. In 12 years, the drought was over. News outlets exploded. Weather.com, first EF5 in 12 years, confirmed in North Dakota. CBS Minnesota, deadly tornado, upgraded to EF5. PBS NewsHour, Weather Service confirms nation's first EF5 since 2013. Associated Press, Fox, CNN. Every outlet ran the story, because this wasn't just a rating change. This was history. Meteorologists who had spent years studying violent tornadoes, who had chased storms across the plains, who had surveyed hundreds of damage paths, they took a collective breath, because this proved it. EF5s were still possible, still happening, still real. The atmosphere hasn't changed. The physics hasn't changed. We just hadn't seen one hit something substantial enough to prove it, until now. So, how did they know? How do you prove EF5 4 months after the event? It comes down to forensics, engineering, precision. The National Weather Service didn't just look at the wreckage and guess. They didn't go by gut feeling or it looked really bad. They brought in experts, structural engineers, wind damage analysts, researchers from the Northern Tornadoes Project, a Canadian-American initiative that pioneered high-resolution damage surveys using drones, satellites, and ground teams. They analyzed everything, starting with the trees. Debarked timber has specific wind speed thresholds, the force required to strip bark from a living tree, factoring in species, diameter, moisture content. It's been studied. It's been tested. The Maple River forest damage, debarking on trunks 8 to 12 inches in diameter, wind speeds, minimum 190 miles per hour, likely higher. That's high-end EF4, or low-end EF5. Next, the transmission towers, steel lattice structures, designed to specific engineering standards, known load capacities. The way they failed, the direction of buckling, the points of fracture, it all tells a story. Engineers calculated the wind loads required to cause that specific failure pattern, over 200 miles per hour, EF5 range. But the trains were the smoking gun because rail cars are uniform. They're built to strict federal standards. Engineers know exactly how much they weigh, both empty and loaded. They know the dimensions, the structural integrity, the failure modes. So when a tanker car weighing conservatively 15 to 20,000 pounds gets lofted 475 feet, you can calculate exactly how much wind force that requires. It's physics, it's math, it's undeniable, mass times acceleration, projectile motion, drag coefficients. The wind speed required to loft that tanker, over 210 miles per hour, guaranteed. That's not EF4. EF4 tops out at 200. That's EF5. And it's not just one data point. It's multiple train cars, multiple failure modes, fully loaded grain hoppers tipped and rolled, tankers displaced, 33 cars affected, every single one telling the same story. Winds, over 210 miles per hour. The math doesn't lie. The steel doesn't lie. EF5. Here's the uncomfortable truth that every meteorologist knows, but the public often doesn't. The enhanced Fujita scale is imperfect. It's a damage scale, not a wind speed scale, which means if a tornado with EF5 winds hits nothing but an empty field, it gets rated EF0, or unrated entirely, because there's no damage to measure. Think about that. 2 identical tornadoes, same wind speeds, same width, same intensity. One hits a well-built suburb, levels homes, gets rated EF4 or EF5. The other hits open farmland, scours the soil, maybe kills some cattle, but no structures. It gets rated EF1, maybe EF2 if it snaps some power poles. Same tornado, different rating. This is called the construction variability problem. And it's been plaguing tornado science for decades, because we can't measure wind speeds inside a tornado reliably. Doppler radar helps, but it measures wind around the tornado, not at the surface where the damage happens. Probes and sensors, they get destroyed, or the tornado misses them. So we're left with damage. And damage depends on what you hit. A poorly built mobile home, that's EF1, EF2 damage, even if the tornado is much stronger. A well-built, properly anchored home with a reinforced roof, that can withstand EF2 winds. You need EF3, EF4 to destroy it. A commercial building with reinforced concrete and steel framing, that might survive EF4. You need EF5 to level it. So, the same tornado can produce EF1, EF3, and EF5 damage, along the same path, depending on what it hits. For years, scientists have debated how to fix this. Mobile Doppler radar helps. We can get wind speed estimates. Satellite imagery helps. High-resolution before and after photos, drone surveys, LiDAR, computer modeling. But ultimately, we rate by what we see destroyed. And at Enderlin, the trains provided the proof, because trains are consistent. Every BNSF grain hopper is built to the same specs. Every tanker has known dimensions. So, when you see them tossed, lofted, displaced, you know what wind speeds that requires. No guesswork, no variability, just engineering. And that's why the upgrade happened. Not because someone felt like it was EF5, but because the evidence demanded it. Enderlin's tornado is now legendary, historic. The first U.S. EF5 in 12 years. But it's not North Dakota's first brush with top-tier tornadoes. Not even close. June 20th, 1957. Fargo, North Dakota. An F5 under the old Fujita scale, before the enhanced version, before detailed damage indicators, but F5 nonetheless. It tore through the northern part of Fargo. 9 people killed, hundreds injured, entire neighborhoods leveled. Eyewitnesses described a wedge tornado, maybe a half-mile wide, churning through town at dusk. Cars tossed, homes obliterated, the kind of damage that leaves you speechless. June 21st, 1953. Fort Rice, North Dakota. Another F5. This one hit a tiny community in Morton County. 1 fatality, but absolute devastation. Buildings swept clean, nothing left. North Dakota knows tornadoes. The northern plains, despite their reputation for brutal winters, blizzards, and cold, are no stranger to violent severe weather, because the same geography that brings Arctic cold in winter brings Gulf moisture in summer, and when those air masses collide, you get explosive thunderstorms, supercells, derechos, tornadoes. North Dakota averages 32 tornadoes per year. Most are weak. EF0, EF1, brief touchdowns in open country. But every few years, something violent happens. And Enderlin is the latest chapter in that history. But it's also different, because it's the first EF5 under the enhanced Fujita scale, the modern system, adopted in 2007, that uses detailed damage indicators and engineering thresholds. The old F scale was subjective, based mostly on appearance and reasonably well-constructed homes. The EF scale is more rigorous, based on 28 damage indicators, each with multiple degrees of damage. It's harder to reach EF5 under the enhanced scale. You need specific types of damage, provable, measurable, engineering-based, and Enderlin met that threshold, which makes it historic. 4 months after the tornado, Enderlin is still recovering. Tyler and Brooke Pfaff have rebuilt, not their home yet. That takes time, permits, insurance, money, but their lives. They're staying with family. They've salvaged what they could. Photos, a few pieces of furniture, keepsakes. They held a memorial for Michael and Katherine Dehn. Family, friends, the whole community showed up. There were tears, stories, laughter mixed with grief. Because that's what small towns do. They remember, they honor, they hold each other up. The Lucio family held a service too. 89 years, a long life, but still too short. Volunteers spent weeks clearing debris, chainsaws running from dawn to dusk, trucks hauling away splintered wood, twisted metal, remnants of lives upended. The Maple River forest will take decades to recover. Those trees were old, mature. You can't replant a forest and have it back in a year, but saplings have been planted, slowly, carefully. Nature will heal. It just takes time. The train cars have been removed, the tracks repaired. BNSF crews worked around the clock. Within 2 weeks, trains were running again. Because the harvest doesn't stop. The economy doesn't stop. Life goes on. Enderlin's main street, spared by the tornado, looks normal. The grocery store is open. The post office is operating. The high school started classes on time in the fall. But drive a few miles southeast, and you still see the scars. Empty foundations, cleared lots where homes used to be, fields still showing faint track marks, and in the hearts of the survivors, scars that will never fully heal. So, what changed? The record books changed. The National Oceanic and Atmospheric Administration's tornado database now lists Enderlin as EF5. Textbooks will be updated, Wikipedia pages edited, meteorology courses will cite this case study. The 12-year EF5 drought is over. The question of, are we still seeing violent tornadoes, has been answered. Yes. Yes, we are. Warning systems will be analyzed. Did people get enough notice? Were the warnings clear? Mostly, yes. The tornado warning was out 12 minutes before touchdown. People in the path had time to shelter. The deaths weren't from lack of warning. They were from the sheer overwhelming power of the storm and the vulnerability of the structures in its path. Construction codes will be reviewed. Engineers will study the failure modes. Maybe, we learn how to build homes that can withstand EF5 winds. But probably not, because EF5 winds 210 miles per hour. That's beyond most residential construction capacity. You'd need a bunker, a reinforced concrete shell, something that costs more than most homes themselves. So, we build shelters instead. Community safe rooms, school tornado shelters, basements, places to survive, even if the home doesn't. Communities across Tornado Alley will look at Enderlin and ask, are we ready? Do we have shelters? Do our people know what to do? And maybe, more lives will be saved next time because of Enderlin's story. That's what changed. But here's what didn't change. Michael Dehn is still gone. Katherine Dehn is still gone. Macario Lucio is still gone. No rating upgrade brings them back. No engineering analysis undoes their loss. Tyler and Brooke Pfaff still have to rebuild their lives from scratch. Their home is gone. Their sense of safety, shattered. You can build a new house, but you can't rebuild the feeling of home. Not easily, not quickly. Enderlin still has a scar across its countryside. You can see it from space. You'll see it for years, because an EF5 doesn't just damage, it erases. And some things, once erased, can't be brought back. But what an EF5 rating does do is honor the truth. It says, this is what happened. This is how strong it was. This is what it took. It validates the survivors' experiences. When Tyler says, it sounded like the world was ending, the EF5 rating says, yes, it was. It informs future preparedness. When emergency managers plan for the worst-case scenario, they now know EF5s are still possible. It advances science, the train car analysis, the debarked tree thresholds, the collaboration between meteorologists and engineers. That methodology will be used for future tornadoes. We'll get better at rating them, more accurate, more consistent. And maybe, it helps us prepare better next time, because there will be a next time. Tornadoes don't stop. EF5s don't disappear just because we go 12 years without one. The atmosphere doesn't care about droughts or statistics or human timelines. It just does what it does. And when it does, we measure, we analyze, we remember. We remember the night of June 20th, 2025. We remember 19 minutes. We remember the town that was spared and the families that weren't. Standing in that Maple River forest today, you can still see the stumps, pale, weathered now, but still bare. The wind whispers through what's left, and if you close your eyes, you can almost hear it. That roar, that impossible, overwhelming force that scraped this place clean. EF5 isn't just a rating. It's not just a number on a scale. It's power, pure, undiluted, unstoppable. It's the atmosphere at its most violent. It's most awesome in the old sense of that word. Awe and terror. And for 19 minutes, that power visited North Dakota. It took 3 lives. It destroyed homes. It threw train cars like confetti. And it reminded us that nature, at its most powerful, is humbling. It doesn't negotiate. It doesn't compromise. It just is. And all we can do is prepare, shelter, survive, and when it's over, we pick up the pieces, we rebuild, we remember, we honor those we lost, we celebrate those who survived, and we keep watching the sky, because the next storm is always coming, the next warning will always sound, and somewhere, someday, another EF5 will touch down. We just don't know where or when, but we'll be ready, because Enderlin taught us, the drought is over, the monsters are still out there, and they're not going away.